Fine. We have not yet not completed the we have not completed this problem yesterday. So let me quickly finish it. You know, it is we are considering a certain volume of material which is placed in the space and under Cartesian coordinates x, y, z. And what is happening? We are considering a point on this body whose coordinates are known to us. And due to the application of some external forces over this body changes its shape. And as a result, the point which was initially position was denoted by P and with coordinates x, y, z, changes its position to a new places and with new coordinates under the same coordinate system. So what happened when it is displaced from P to P dash? There are two positions. One is P, and there is another position, and one that is P dash. So that uh, there is another position that is P dash. So there is a length in between from P to P dash. The P is displacement displaced from P to P dash itself. And you know, as per our vector analysis, there is a displacement vector P to P dash exists. Now, this displacement vector, what we think that as this particular volume is infinitesimally small and its surrounding points are very close to each other, but not close to each other, their same displacement vector is applicable to all movements from P to P dash. Only if the same displacement vector is applicable to all points whose coordinates are known, and we can use this displacement vector for to know their final position. And now we have gone through how we can use this vector like this. There is another example here. Here, this displacement vector, common displacement field, which is called displacement field, which is common to this particular body for applicable to all points whose under this particular Cartesian coordinates is whose coordinates are known, is given by u x y in x y I 3x square z 3x square j into j z into j 3x square z into j plus 4k whole multiplied by 10 to the power minus 2 or 1 by 100. Now let us have a point P, and in the neighborhood we had another point Q whose so this direction cosine of this line PQ is given. NX is 0.2, NY is 0.8, and NZ is 0.555. What is direction cosine? Is this displacement vector PQ is considered the angle it makes with x, y, and z axis. The cosine of the angle it makes with x, y, and z axis is called displacement vector. It is actually it gives us the coordinates of the points Q. If we add this cosine direction cosine with the coordinates of P itself. Now we have what is given to us is the coordinates of P, and what is given to us the direction cosine of PQ itself. But the coordinates of Q is not known to us, and it is like this. If PQ is given a length delta s, which is not numerically given, but the value is in term is given, so we have to find out the what is the component of P dash and Q dash after deformation. Here we got P is displacement to P dash, and Q, which is at the neighborhood of P, it displaced to Q dash. So, but this length P is not P dash Q dash, although very close to PQ, but not equal to Q. So you have to know the value of coordinates P, and you have to know the coordinate value of the coordinates Q. If you know for this problem, in order to know the component of P dash Q dash. So what we do like this, Before the deformation, the components PQ are given as delta x multiplied nx multiplied by delta s, where nx is the differential direction cosine, and pq is the length. Pq delta is the length of pq. So delta x, the coordinates of pq will be given as delta x into direction cosine of delta s and multiplied by delta s itself. So it is equal to 0.8. Similarly, delta y direction cosine is equal to the direction cosine multiplied by the length of PQ, which is the coordinates change in coordinates along the y direction, is equal to zero point 0.8 delta s. Delta z is equal to nz into delta s, which is equal to 0.55 delta s. So we have got, from the equation we got the value of ux. And from our earlier discussion, we have to got the value of delta ux, delta uy, and delta uj, because we know the direction cosines of pq will not be the pq will not be equal to the direction cosines of p dash q dash. That's because it's also due to change in position. It also changes to its value, maybe very small, infinitesimally small, but it is given, it is different. So you have to calculate what is the change in the direction cosine, or what is the change in ux, uy, and uz. So from the value, from the displacement vector of u, vector base of pq, or displacement vector of u, it is given here xii plus 3x squared z into j 4 into k whole multiplied 1 by 10. So we can use our earlier discussed formula, where we have to calculate here from the that's which is like this, from the displacement field. Thus we have got, in terms of xy, the ux is equal to p into xy, y is equal to 3 into px square and us square, and x square z, and uz is equal to 4 into p. Now, in order to know the change in delta x ux, or delta x uy, and delta x uz, we have already reduced how we can go to it. We have to find out the rate of change of differential equation value, or rate of change of ux in terms of x, rate of change of uz in terms of x, and rate of change of uz, uy in terms of x itself. Similarly, for ux, uy, rate of change of ux, uy, and uz, we have to measure, we have to calculate in terms of against dy, in terms of y, and in terms of z. So the rate of change of ux, the direction cosine, we have to calculate for all we have to calculate in terms of x, and in terms of y, and in terms of z, means how much it is changing along x-axis, along y-axis, and along z-axis. We have to calculate in order to know the coordinates of the value q itself. So here there are three equations: delta ux into py. If we derive delta ux, if we derivative delta ux by dx, we will get p into y. It will get delta uh, yes, for delta ux here, delta uy, rate of change of delta uy in terms of x is equal to 0, because there is no a terms. Just 1 second. Delta uy will be not 0. It is wrongly written. It is px square, and uh, delta uz, uh, delta uz by z will be equal to 0, because there is no x, y, or z in this equation itself. So if we derive, again I am telling you, if we derive if we make the derivation of ux in terms of x, which is ux is given as pxy, it will become py. If you make the derivation of uy in terms of x, it will get px square. It is wrongly written. Don't get confused. It will be px 3 ps square, and the rate of derivative of uz, if we make with respect to x, it will be equal to 0. Similarly, for y, if we make ux, if we make derivative of ux in terms of y, it will become px. If we make derivative in terms of uy in terms of y, it will get px square itself. It will again get px square itself, and now it is actually, it will be equal to 0 again. Uh, Derivative of ux and delta y is equal to px, derivative uy and delta y is equal to, uh, it will also equal to 0, and derivative of uz is also equal to 0 itself. Same is the cases with here. So this equation, this result is wrong, and this result is also wrong, wrongly written by me. So don't get this confused. Just clear and direction will give you the result itself. Next, let me go to the next one. Just 1 second. Stop share and get the participants. Just 1 second. Similarly, ux, if you derive ux, uy, and uz in terms of z, you will get 0. The derivation of uy will be 3 px square, because it has a z. Here it will again equal to 0. So what we'll do at the point 3 is, what is the delta x, delta dx? As per our relation, as per the equation we have derived already, delta ux will be dx, dux by dy, which you have calculated as y and multiplied by delta x, and dux by dy, which is also equal to x and multiplied by delta y itself multiplied by p. So this will be in by after simplification, it will become delta x plus 2 delta y into p. And what about the delta uz is equal to delta uy 6 uz. We have got this value into delta x. We have got this for delta z. It has got this value multiplied by delta j into p. P is common to everybody. So 12, and now delta z is equal to 0, because all three are equal to 0 itself. Now if we put the value of x equal to 2, y is equal to 1, and z is equal to 3 in this equation, it will take this particular form, delta x into 2 delta y p, where p is known to us equal to 1 by 100, 36 delta x, 12 delta x, and 12 delta z. It is delta z into p, and if z is equal to 0. Now substituting delta x, thus we have got delta x, delta y, and delta z, ux, uy, delta ux, delta ux, uy, and delta uj. So delta dash component delta dash u dash is equal to p dash q dash. So it will our components are like this: delta y, delta y plus delta uz. We put the value of y and z and add together, and this will become 0.072 0.8 into 0.067 into delta s. That will be equal to 0.0939 delta s. Delta x plus delta ux is given by this equation. We have added the value of delta x with delta y with this equation here, the initial equation. This will become take the form like this. And so we have got, and similarly we have got delta z plus delta uz. So it is equal to 0.55 delta x. So the new further vector p dash q dash will be given with these vectors. One, this is for delta x, this is given for delta ux, this is for uz, uy, and this is for uz. So put all of them to get the coordinate, to get this displacement vector p dash q dash here, because we have already calculated the displacement vectors or even nx change of nx or reaction cosines here. Thus, this is another type of problem which is more or less comparatively difficult but simple matter. Let us go for the next one. Here, we are trying to think the changing length of a linear element. We have just so far we have discussed the change in position of a particular element, its particular points itself. But now let us go think of going what will be the change of a linear element itself, which is a line for due to the deformation of its of the body with from where it is belong to. What will be the deformation caused by this point, because deformation caused by this linear element or line. I know what we have done so far. Deformation causes a point P. That is the point P whose coordinates are given as x, y, z in a Cartesian coordinate system, x, y, and z in the solid, under consideration to be displaced in new position P dash. So here P is changing to P dash with coordinates x plus ux, y plus uy, and z plus uz, where ux, uy, and uz are the displacement components. Here we are not saying delta x, delta y, or delta z, because we are clearly saying that this is a straight line from P to P dash, where whose displacement components or reaction cosines are known. So it should just to be added with x, with x, and with y, and with z, because these displacement coordinates will give you the displacement along x-axis, y-axis, and z-axis. So in order to know the coordinates of this point P dash, we'll just simply add this value of coordination cosine ux, uy, and uz to the corresponding value of x, y, and z itself. Now, next, again, we are considering a neighboring point Q, which has coordinates delta x plus delta x, y plus delta y, and x plus delta z. So we are going back to the same conception. We have a neighboring point which is very close to x, but not coincides with x. Its coordinates are given by with the we'll add the amount delta x, delta y, or delta z with the coordinates of P. So the coordinates of Q is x plus delta x, y plus delta z, and x plus z plus delta z. Now, the coordinates, the P point P, again as per our earlier discussion, is also displacement changes position from Q dash. So we are getting a linear length PQ, which is changing to a new position P dash Q dash. And for our, as per our earlier discussion, the coordinates of Q dash will become x plus delta x plus ux plus delta ux, y plus delta y plus uy plus delta y, and z plus delta z, uz plus delta z itself. So it is possible to determine the change in length of the line element PQ caused by the deformation. So far, our earlier discussion, we have wanted to know the coordinates of Q dash, P dash, and Q dash, and that finishes our job. Now we are considering of know the change in length of the uh, element PQ when it changes position to P dash Q dash. Total the length of the element, not only the coordinates of the itself. But of course, we have to know the coordinates. You have to know the if you want to know the length. Now delta S is the length of the line segment PQ and cost line of the PQ which is under deformation itself. Initially, after it is deformed, it becomes initially it's a change in delta S. Uh, Change in length of the delta S will be given by delta X, delta Y, and delta Z, and delta S square will be PQ delta X whole square plus delta Y whole square plus delta Z square itself. Now, you know what we are saying that why it is delta X, delta Y, and delta Z. The PQ from P to P dash, Q to Q dash. There are two equations we have just discussed here. P is the initial point, P dash is the final point of P, and Q dash is the initial point of Q, and Q dash is the final point of P. So P has the coordinate x plus delta x and Q, and Q has the coordinate x plus delta x. P has a coordinate x, y, z, and Q has a coordinate delta x, delta y, and delta z. So the change in length of PQ is the length PQ, which is given as delta x, due to which is given as delta s here, will be given by the coordinates delta x, delta y, and delta z. Means this was the amount of change in position as takes place from the point P to the point Q. It is the difference in coordinates of the point P and the point P Q. That's the difference is delta S, delta Y, and delta Z respectively. So delta S will be the square root of their individual square of their individual value of this element itself. So delta S square is equal to PQ square is equal to delta S x square plus delta Y square plus delta Z square. Okay. Now, this is the change of length. This is the length, I mean the length of PQ, which is delta S square, or you can make the square root if you like. It is not necessary for this time point of view, for our point of discussion. So delta S, the initial length of PQ, we know as square root of delta S square, Y square, and Z square itself. Now, due to the change in position of PQ to P dash Q dash, we are also thinking that we are sure that length delta S is supposed to change at delta S dash, which is the length of P dash Q dash. So its component will be like this: delta X dash, delta S dash is equal to delta X plus delta UX, delta Y dash, so delta Y plus delta UY, and delta Z dash is equal to delta Z plus delta US. As we know, that as the delta X dash or coordinates of Q dash is changing, and in order to know the change, we have to add the with the value of delta x, that change of the value of ux or the direction cosine along x-axis, and delta y plus delta uy with the direction cosine, change in direction cosine along ux y direction, and delta z is the delta us, which is the rate of change of direction cosine along the z axis itself. So what we have, delta s dash square, s dash, which is not 12 but s dash square, is p dash q dash into p dash and q dash to the power 2. So it will be had for the from the same reason, it will be equal to delta x plus delta ux whole square, delta y plus delta ux uy whole square, plus delta z plus delta uz whole square itself. So what happens here? So what happens here? We know from the earlier points, our earlier solutions, 4, 5, and 6. From our earlier solution, just 1 second, please. One second. 27 ABC 27. Hmm. Okay. Now, now what we have got from our uh, solution here, that is from number 4. I have not opened. Hmm. Hmm. We have that relation, the I'm just narrating delta ux, the dux by dy, delta ux is dux by dy multiplied by delta x, and dux by dy multiplied by delta y, and delta uj ux by dy multiplied by delta z. That is the change rate of change of delta ux, say. So what will happen here? What will happen here? Delta x is equal to uh, delta x square is equal to 1 plus dux plus dx, because already we have delta x here, delta x plus delta uz plus delta y, and there was no delta y or delta z here, so here remains equation remains as it is, like this. This is the change in delta x dash, which is the coordinates of p dash. Same is equal to delta y. Here delta uy dx plus delta x plus 1 means either delta y plus delta uy by delta y into y. So it is added with the original coordinates delta y itself of the point q itself. So same is the case with delta z. It is added. Others two are same, and one delta it is so equal to delta z. Delta z equal to delta z is delta ux by dx into 1 plus y itself. This is wrong. This is delta z. So many things I have to rectify. Okay. Let us stop share. Go for 6, 5, 6, 7. So we have got delta s dash square and delta s square, and thus p dash q dash square minus p dash q dash square is equal to delta s dash square minus delta s square itself. So what is happening here? The delta s dash just we have derived delta y dash square and delta z square minus delta x square minus plus delta y square delta z square. This is the change in length of which was initially it was pq, and finally it is p dash q dash itself. Now what will happen here? If we now put the value of delta x and delta x dash square here, just we add and make it square, delta y dash square make it square, delta z square make it square, and delta square delta y square delta z square here, and make the simplification, the equation will kind reduce to here. That's a big quadratic equation. After simplification, it will take this particular formation where we are using the term exs, ex eyy, ezz, and exy, ezi, and az, eyz. This equation, if you put the value and make the simplification, it will come to here. But we don't have to bother for that big tedious simplification, because most of these sums will be rejected in afterwards. We will show you afterwards. So don't be anxious, because this big equation is extremely difficult to solve here, not even in class or not even by you. So what happens is, what is given told us, that is exs, the elongation is del ux plus del y plus half dux dot dux square plus dy square and dux and dux square itself. So what is shown is exs is all the change in x, y, and z. Here first dux and dx, and half multiplied by ux by ex and uy by dx and uz by dx. So here there is always the derivation in terms of x itself, and ux, uy, and ez whole are multiplied by square. This much you have to remember in for writing. How it comes, it is not required for our subject point of view, because it is very clear that it will come for putting the value of a, but that's a big quadratic equation, and we don't have to do for that. We have to cover for the other words itself. Same is case eyy. Here the rate of change of uy by delta y plus the square of rate of change of ux y in terms of y, that of rate of change of uy in terms of s dy, and that of uz in terms of uy itself. Each z same rate of change of uz and zz, and similarly for all the values of z, and for the ux uy and z for rate, it is all their rate of change in terms of z itself. There are other terms like exy, yz, and uz. It is derived like this: ux dy, uy by ux, and next that xy. This is x and this is y. Then this plus this, then this multiplied by this here in terms of x and y. This uy, both are uy multiplied with del x and del y, and del uz multiplied by del uz dx and dy itself. Same is the case of these six are very big and tedious equation. So we'll soon go to the simpler form of it. Say similarly, yz, dyz, duy, duz, both are derivations made by of the differential of dz and dy. Same, this is the multiplication of ux, the differential of with uy, uz, uy, uz, dy, dx, and uy, uz. Similarly, we have got the exj. We know it is observed that the value of exy is equal to eyx, eyz is equal to eyx, and so is equal to ezx equal to exx. So the strain or rate of deformation of PQ is given as rate of change of final length by the initial length divided by the initial length itself. So PQ, EPQ is the ratio of increase in distance between P and Q caused by differential of their initial distance, deformation up to their caused by the deformation to their initial distance. So this is we want to know what is PQ, what is the rate of change of the length PQ due to the deformation takes place due to some additional force, and where their endpoints are changed its position, and thus its length is also changed, and what will be the change in length itself. This is the relative extension. This quantity is defined as the relative extension of the point P in the direction of point Q. Relative extension or strain. Let us go for the next page to finish this. Stop share. 6, 7, 8. Now let us derive another new term, delta s s dash square minus delta s divided by 2, and delta dash s minus delta s divided by s, which can be simplified to take this position: delta dash s minus delta s by delta s, and delta dash s by minus delta s whole square divided by delta a square multiplied by 2, and whole multiplied by delta s square. So this equation can be arrived here after making this simplification or making this modification increase, and this is, delta s dash by delta s by dash is given as, just we have derived this PQ, EPQ, and half of this is also EPQ square, half into EPQ square multiplied by delta s square. So this is the, say, EP plus, if we take EPQ outside, so it will take EPQ 1 plus half EPQ multiplied by delta s square. Now what we are doing next, we are going to equation 10 for to substitute the value of equation not 6 but 10 for to substitute the value of delta s square by delta s, which is that equation here. This is the equation, particular equation here I'm showing you again. That is the same. 7. We are getting this equation. This is this equation 9 where where we can have now this delta S dash square minus delta S square in terms of PQ, in terms of EQ and half EQ into delta S square itself. So here, if we put the value of delta S square and delta S square minus delta S square, what will happen to the position? Let us examine. That is 8. Now, if you put this value, this equation will PQ, EPQ, half PQS delta S square, it will become in terms of EXS, EYY, and EXY, etc. In that, the equation reduced to in this position here. And if NX, NY, or NZ are the direction cosines of PQ itself, then NX will be delta X by S, NY will be delta Y by Z, delta S, and NZ is equal to delta Y by S, because this is all the cosine of the constant angle between XY of the line PQ with XYZ equation. So here we can replace delta X square here, here, and here, and everywhere here in terms of nx. This equation will reduce to this equation if PQ 1 plus half A and AX square, NS square, etc. So, and delta S square will be cancelled from both sides. So this equation will take this particular form here itself. This equation gives us the relative value of the direction extension, relative value of the relative extension at the point P in the direction PQ with direction cosine nx, ny, and nz. And if the line segment is parallel to the x-axis before deformation, then nx is equal to 1 and ny is equal to 0. Then ex, they are not PQ but ex, and now here is not PQ by ex, will reduce to exs because all others became equal to 0, or ex, or the change of length along length PQ along x-axis is equal to given by this form itself. Similarly, the change along y-axis and along z-axis can be easily calculated as under itself. So this equation, this is the relative extension equation when PQ is in along x is not along xyz is at an angle with xyz direction, and this is the relation value of x and uy and gz when the length PQ is along x-axis, along y-axis, and along z-axis itself. And then the elongation or contraction or relative extension, what we are told here, of the line PQ is given by this 4 equation here, 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 and here. These are the 4 forms of the line PQ itself. Okay. With this, I am finishing this lecture today. Tomorrow I'll go for, and Monday I'll go for this linear extension itself. Thanks for patient hearing itself.